So good morning students. So now we are going to see about and we are going to do the experiment on characteristics, VI characteristics of triac. So by here this is the circuit diagram of our triac. So here we have 3 meters. So these meters used to measure the main terminal current or the current flowing in between this loop or MT1 and MT2, and this voltmeter is connected across this device to measure the voltage applied in between main terminal 2 and the main terminal 1, and this is the meter used to measure the gate current flowing through the gate. So this triac is a current controlled device and it is similar to our SCR. So the difference is SCR is a bidirectional, unidirectional device, and this triac is a bidirectional device. So SCR is conducting in only one direction. So the current can be flowed, and that current will be flowing between anode to cathode, and it will not flow from cathode to anode terminal. But in the triac, the current direction is depending upon the polarity of the source connected. So we are calling it as a bidirectional device. So that is the advantages of our triac, and we are using this triac in the AC voltage controller, or we can use it in the regulator to control the fan speed. Okay, so this is the real-time application, and here we have these equipments to conduct this experiment. So here I selected 10 ampere meter to measure the gate current of the triac, and here I selected 500 milliammeter to measure the anode current or the main terminal current, and this is the meter used to measure the voltage across the triac. So these 3 meters are needed, and these 3 are the MC meters, and it can be used to measure the DC parameters. Okay, then as like our other experiments, here I need a firing unit, triac firing unit, to trigger the gate terminal of the triac. And here it is a triac module, and here we have MT1, MT2. So these two are the main terminals of the triac, and another 2 terminals, gate and cathode. So these two are available. Okay, so this is the main terminals. Okay, and in order to restrict the current flowing in between MT1 and MT2 terminals, we need a resistive box. So this module consisting of resistive elements and capacitive elements. So I am going to use this resistive element to limit the current flowing through the main terminal. And in order to power these circuits, I need a RPS. So this is a 0 to 30 volt RPS, and I can adjust the voltage of the RPS from 0 to 30 volt. So that can give 0 to 30 volt at the output terminals. So here we have 3 knobs to vary the voltage, output voltage of the devices, and one terminal is for setting the current. Okay, so this meter can be used up to 2 ampere. This RPS can be used up to 2 amperes, and by varying this knob I can fix the current rating of the regulated power supply. Okay, and here for coarse tuning, so I have a voltmeter. I have a 2 knobs. So one for adjusting the voltages minimally, and one for the higher variation. Okay, so these are about the experiments. So now I am going to connect these devices in order to get the VI characteristics of the triac. So this device is for main terminal side, and this is for giving the firing pulses for the gate terminal, or it can be used to give vary the current applied to the gate terminal. So for that I have the meters to measure the gate current. So I arranged the circuit, arrange the equipment. So now I am going to connect these meters and the equipments. Okay. So here I am going to connect the output terminal of the Triac module and the ammeter, and the output of the ammeter to gate terminal. So it will measure the current flowing through the gate terminal. So to avoid the confusions, I am going to keep this as here. Okay. And now I should connect the another terminal of the firing unit. Okay, so this is the negative terminal and it is connected with the MT1 terminal. So it is connected in between gate and MT1 terminal. So this portion is completed, right? So this is the positive terminal. Here I am not connected any resistance. Okay, so here I connected this positive terminal to ammeter, then ammeter negative to gate, and another terminal of the firing unit is connected with the MT1. So likewise. Okay, so this portion is completed. So now I am going to connect the another portion of the circuit. Okay, and here I am going to use the resistance or resistive module to limit the current flowing through the main terminals. So here I am connecting the RPS positive terminal. This is the positive terminal of the RPS to the resistance box. So we can select 250 or 100 to limit the current. So if you are connecting 100, so then the maximum current of the circuits will be 30 volt by 100. So that is the maximum current of, that will be the maximum current of the circuit. So here I selected 250 as a resistance to limit the main terminal's current. So positive terminal is given to the resistance and the output of the resistance is connected with the ammeter. Okay, then the output of the ammeter is connected with the input terminal or MT1 terminal, MT1 or MT2. So already MT1 is connected, so I can connect it then MT2. Okay, the output of the ammeter is connected with MT2. Then the MT1 terminal should be connected with the negative terminal of the RPS. Okay. Then so these series connections are completed. Positive terminal is connected with the resistance. Then output of the resistor is connected with the ammeter positive. Then ammeter negative terminal is connected with the MT2. Then the MT1 is directly connected with the negative terminal of the RPS. So this portion of the circuit done. Then the another remaining connection is this voltmeter, connection of the voltmeter across the device terminals. So for that I need 2 wires to connect this meter. So this is the voltmeter, and now I am going to connect this voltmeter across the terminals of the SCR. So this is the positive terminal and this is the negative terminal of the source. So if you are not connecting this meter properly, so that will reflected in the anti-clockwise directions. That needle will move in the anti-clockwise direction. So the connection is over. So now before going to switch on this circuit, I should ensure the zero position of all knobs except this current knob. Okay, so these are in zero and I am fixing this current at 2 ampere. Otherwise this may arise beep sound. So whenever the current actual current is increasing to beyond the set value, so that will be indicated by giving the beep sound. So in order to avoid that, so we have to keep it in the 2 ampere. Okay, so everything is done. So now that circuit is ready to take the readings. Okay, so now I am going to record the VI characteristics of this SCR and I am going to tabulate these values. So For that I am going to vary the gate current applied to this, and I am going to fix two gate currents for the triac, and I am going to take the values for the different value of voltage. Okay, so I am going to switch on the power the circuits. So here we have a voltage measuring option that is there in the voltage measurement, and if you want to measure the current, we can shift this knob position to ampere. Okay, so now I am increasing the gate current. You closely monitor this meter, and before that I should switch on. So it is powered on, and it is in the internal pulse generation. So when you are varying, so that varies the corresponding current applied to the gate terminal of the triac. You see here. So when I am varying or adjusting this knob slowly, so then it is reflected in the gate current of the triac. Okay, so there is a closed path, so then only it is creating a current. Okay, so now I am fixing it in the gate current at 4 milliampere, and after that I am going to vary the voltage applied in between the SIRs, main terminals of the triac. You see here, you note down the firing angle. So just I am going to down this because the device is breakdown. So you watch down the voltmeter. So now the device is in off state. So the voltage applied to the main terminals are increasing. So the device is in off state, and when the applied voltage across the main terminals MT1 and MT2 crosses 4 volt, the device is coming to the breakdown. Now you see, when the device break down, then the voltage will come down, then the current is starting to rise, right? You see here the voltage is coming down, and now the current is increasing. Okay, so you see that here I applied to 23 volt, and correspondingly the current is there. So if you are shifting this resistance to 100 ohm, we can see the higher value of current. So it should be selected based on the current capacity of this triac. Okay, so here I fixed the IG, and I am varying the voltage applied in between the MT1 and MT2 terminal. So first I should take the values for 4 milliampere or 3 milliampere current. So after that I should check, I should set the gate current to higher ampere, so that may be 4 ampere or 5 ampere. So when you are increasing the gate current of this triac, so that will automatically reduces the breakdown voltage, forward breakdown voltage or reverse breakdown voltage of the triac. Okay, so that depends on, and here I am going to tabulate these values. Okay, so for the different value of voltage, I am going to mark down the anode and anode current of the device. So I have to record these values, and I should conduct the same kinds of procedure for taking the readings for another value of Ig, and here we should keep the values of the voltage at same value. So then only we can see the difference in the ampere. Okay, so here you see that there is a variation in the gate current. Okay, so this is about the characteristics of our triac. Thank you.